Hi, this is another video walkthrough for your homework assignment. I have assigned 3 questions here that can be used to help you understand more about the various statistical testings we have learned during this week's class. So there are something that I should address because you may feel, some kind of skill shortages in dealing with this type of questions, especially with Excel. So I just want to help you touch those areas. I'm not gonna give you the full solutions in this video, okay? But I will eventually provide you with a full solution. So number one, it's using a quality measure data. So it says the 15% defect rate is their belief, and this is a definition of defect. If this is outside, if the certain part is outside of this quality measure, it is being considered as a defect. So the first question says to please identify all the defective parts and label them with a 1. And non-defective parts will be labeled as 0. You will need to create a new column to store that information. So if you look at the data file here, this is a quality measure, and this is the interval for non-defective parts. So what I'm gonna do, you may use your own method, okay, but I find this way is more convenient for me. So I wish you can learn this from me if you're kind of new to this type of approach. Too small and too large. Too large and defect. Okay? And I'll say if it's smaller than the lowest value, I will call this as a defect because it's too small. Otherwise, it's 0. Okay, the same here. If this guy is larger than the largest value, sorry, my daughter called. If it's larger than 13.4, it's called a defect because being too large, and otherwise it's 0. Okay, so all you need to do here is to sum these two values, because only one of them is gonna return as true if this is a defect. Okay, when this is done, for example, this guy is larger than 13.4, so it flagged it as a defect. So double click it. I think we're done with this. So the column D will contain information about whether all these individual items are defect or not, and with that we're going to draw samples using column D. Okay, so we do that. I think the second requirement here is random sample of 36, right? So what I'm going to do here is sample. I'm going to draw random sample of 36. Sampling. And then input range, the label, randomly 36. I'm going to output it here in H. Click OK. So you got 36 samples here. So we don't really know what their specific measures are, but we don't really care because we only need to know whether we have picked a defect or not. Okay? But in real world situation, you may be touching the actual product that you can feel that it is actually a defect. But here, I think that's enough. So based on the claim of the firm, if you are to conduct a hypothesis testing to evaluate the claim, what is the property of the distribution you will be relying on? So this is indirectly asking you, what distribution would you use to answer this question, to conduct a hypothesis testing? Of course, if you're using a sample, right? If you're a sample, which type of distribution you will be relying on. Okay, and then here, I'm just gonna calculate what is the proportion average. What is a proportion? So for the proportion, you can just do average here. Okay, so that will return you the proportion. So the first sample has returned 27.777%. Okay, so I think then you get the idea, right? Please evaluate the probability of obtaining the sample proportion like yours. Okay, assuming the claim of 15% defect is true. So you need to, I think you need to somehow combine C and D to answer both questions correctly. This is the sample we have obtained. Okay, this is the sample we have obtained. What is the likelihood of obtaining this type of sample, assuming the hypothesis is true? So a lot of things will be determined by the default claim, but I will leave the rest to you to figure it out. Okay, so I think the most difficult part in this problem is actually the flagging the defect parts and then figuring out which probability to use. I think you're good with this. So moving on to number 2, this is Maggie's French fry study. You should briefly take a look at the textbook to see what's the context of the problem. If you're using an older version of the textbook, you can still see this problem there. If you don't see that, please let me know. I can show you a little bit. Data file is attached. So the data file here is the Maggie's French fries, and this will be the data set that you will be seeing. I think you will need a little bit more effort in this particular problem since it is asking you to do something that I have not showed in the class. So here is, if you look at the data, we can take a look at all these variables, right? The first variable is location, and second variable is fry number. So basically this person is randomly sampling fries to see what is the size of, what is the length of the fries, and what is the proportion of defect and things like that. So here I think the first question is asking you to compare the length, compare the mean of two locations, compare the mean of two locations. I should say compare the mean lengths, mean fries lengths, okay, of two locations. Fries length. Should I do apostrophe? Okay, then establish a statistical significance. So basically I'm asking you to do a t-testing on this particular situation so that you can arrive at a conclusion with whether these two locations has the same length fries. Okay, so the null hypothesis in this case is whether these two locations are the same. Therefore, equality is something you want to looking for. So you're going to do a two-sided test, two-tailed test. So you can just do the Excel t-test from the data analysis component. Most students didn't have a problem with this, so I trust it should be fine with you. And if the standard error of the sampling distribution of the mean difference is this, okay, remember that here I'm sorry. Basically, I'm asking you to calculate the confidence interval here. Confidence interval of the population mean difference, but we can obtain the mean difference, right? And that is first component, and you also need to know what is the standard error. If you remember, the formula for confidence interval was the sample average plus minus number of standard deviation, okay, number of standard deviation, and standard error. So that was sort of the equation in this case you should use. Well, x bar here basically is the mean difference. Okay, mean difference here, and then plus minus z alpha over 2. I think you can just basically take 1.96 for this value because we're looking for 95% confidence interval. Okay, and then I know some of you may argue, shouldn't we use a t here? You can use t, but I think we have a sufficiently large sample size, therefore we can safely use z to replace t. It doesn't really matter too much. Okay, and then the SE. So the difficulty with the question A is that it did not provide with the standard error of the mean difference. That's the reason why I provided this. So with this, you should be able to calculate the confidence interval. Okay, as long as you know what that is. I'm also asking you to explain what that is. Okay, and then compare the non-conforming rate between two locations. then establish a statistical significance on your result. Again, this is the same similar question, but this one is asking you to identify the population proportion difference, okay, and then also put a statistical significance, meaning that what is the chance of obtaining this type of proportion difference, assuming that there's no difference in terms of proportion between two locations. Okay, so I think basically, again, you're testing the hypothesis of this. So let me show you this, because this is something I did not show you in the class, but hoping you can utilize what you have learned to be able to solve this problem. Okay, so I'm just going to give you the hypothesis and then see if you can figure out the rest. Hypothesis and a little bit more, actually. So P1 is equal to P2. We're assuming the proportion of first location, second location is the same. Okay, or we're assuming this proportion here is equal to 0. We are hypothesizing the difference here is equal to 0. Okay, and what else should you do? Right, I think you need to ask, what distribution should I be using? Number 2, what is the hypothesized center? Okay, what is the hypothesized center here? Basically, it's provided here. Number 3 is, what is the standard error? Okay, what is the standard error? So in terms of standard error, excuse me, since we have not learned in the class, I have attached the standard error chart here. Okay, here is the standard error. So you can just use this part as the standard error. So you plug in all the values of P, and then that will give you the standard error. Okay, and then you use standard error, hypothesized center, and it is enough for you to identify or to calculate the probability of obtaining sample size of this size. Okay, so I think this is very detailed explanation and should help you, figure this thing out. And number 4, the D question, is related to what we have done in Thursday's class. Basically, this is a linear equation way of expressing the differences. Like what it says is, y, and I mean, if you remember this, we use this to express the mean difference. Figuring out how B behaves. That is basically how the mean difference is behaving, right? And I'm asking you to do something similar for the proportion difference. Okay, it looks kind of intimidating, but it's really a simple one. Okay, it's really a simple one if you solve D already, or if you solved C already. So let's say y is equal to P1 plus Bx. Okay, where x is between 0 and 1. It's basically a switcher, and B is equal to P2 minus P1, which is basically the proportion difference between second and first. And can you tell me about the behavior of B in this case? So this is different way asking about a question that you already know. Okay, so if you think about this, and if you don't remember, just pay one. Just go back and take a look at the recording just one more time, and you should have no problem figuring this thing out. If it still confuses you, let me know. Okay, we can talk. Number 3 is about the ANOVA. So this is a simple ANOVA problem. I think this is a, I'm asking you to use a subset of the ANOVA data here, which is this. Yeah, I tried to give you, more interesting ANOVA data, but they're really, interesting ANOVA data that is suited for our context is really difficult to find. So I'm asking you to, instead of using the whole data, because I demonstrate everything in the class, so instead of using the whole data, I'm asking you to choose these factor levels, right? 2x2 design. So glass type 2, 3, and temperature 100, 150. So let's go back to the ANOVA data. So this is what it is. You should eliminate this portion, and you should eliminate the middle portion. So this is glass type 2, 3, and temperature 100, 150. And then you run the ANOVA test here. You basically need to run ANOVA test there, and yeah, and then just answer what it is asking. Okay, and one thing is I'm asking you to paste the result in picture. Some of you have asked me repeatedly, so let me show you briefly what that means. So basically, when you copy something from Excel, I'm just copy this proportion back to Excel, back to the Word. You can basically paste it as picture. So if you right click and then you have a paste as picture option. So this is what I'm referring to, okay? So if you do it like this, your report will be look very neat and organized, okay? And what is amount of total variation and things like that, we'll talk about that a lot. Is there any factor turned out to be not introducing? We also talk about this. And I'm also asking you to plot interaction. We did not address the interaction part in full, so I'm planning to explain this a little bit more on Tuesday class. But if you're willing to study on your own, there's materials all over the internet, right? So you can basically take a step ahead to learn what that is. So that is basically everything about the homework. But it looks a lot of questions, but really are just the three things that I'm asking from you, right? Do a hypothesis testing and do or a mean or proportion difference comparison. And number three is do a ANOVA. Okay, so that is it. So see you next Tuesday. Bye.